Hello there everyone, my name is Crazy Caleb and welcome to the long-awaited tutorial for Jumble Cycle. This module, as of right now, as of this recording, is the oldest module to not have a tutorial present, followed by Forget Perspective, Ultimate Cycle, Ultimate Custom Night, and Lines of Code for the year of 2019, the last 5 modules remaining. So today we're going to take a look at this module today, and this module is essentially a way it's essentially a combination of 3 different cycles that were made previously beforehand. That is including Caesar cycle, Affine cycle, 4, Pigpen cycle, and Playfair cycle. So this is going to be a combination of all 4 of these together, and another way that you can tell that this is indeed Jumble cycle is because if you look down at the bottom right, essentially this would be the way that you would determine which cycle you're looking at. This case, it's actually all jumbled up as you would expect. We've got the Pigpen table together there. You've got the affine formula there. You've got the Playfair grid in there as well, and you've got the Caesar somewhere along in the lines there. So, yes, this is going to be indeed Jumble cycle. And also another way that you can tell is by the colors being a wide variety of different colors instead of just one color. For example, Caesar would always be white. The text would always be white for every single one of these. For Pigpen, it would always be purple, or essentially kind of like a purple pinkish sort of color. Affine would be yellow, and Playfair would be a sort of a cyan. The only one that is actually not included in here that doesn't include Cryptic or Ultimate Cycle is indeed Hill Cycle. This was actually included afterwards, but putting Hill Cycle on here would be quite the experience. So let's get right into this, and this is going to be working similar to how all of these cycles works. We're going to try and find a word, and we're going to decrypt a word, and then what we're going to do is we're going to return a response, but in an encrypted fashion. So that's what we're going to be looking at here. And what we have to do is we have to use a wide variety of different ciphers. This module is going to take a while. And actually, one of the things that I will mention is that in a lot of cases, you actually really don't need to do a lot of these ciphers. You can actually simplify this first part of the process here by just skipping over some of the harder ones. For example, like Playfair for the first part. Although keep in mind that you will need it for the second step. You have to have it for the second step. But if you want to skip like the first step a little bit easier, obviously what you can do at this point is simply just try and find a couple letters that match in a specific order, and you can then find your word and then get into the encryption process immediately. It's a very simple process that a lot of people end up using because of the fact that these words are fairly unique from one another. It's like if you can get past the fourth or fifth letter rather, you should be fine. So let's get right into this and let's start covering this thing. So normally with cycles, what would happen here is there would be a series of different rotations. These ones are going to be based off of 45s. So let's note this stuff down. So first things first, let's note down our characters. We've got Papa Tango, Foxtrot Lima, Bravo Uniform, Papa Oscar. And in this case, it's going to be in a zigzag fashion, not in reading order like you would do Papa Foxtrot Bravo Papa, not like that. And what we're going to now do is we're going to note down the rotations. In this case, that's going to be starting from north. 45-degree rotations work something like this. This is starting from north. Then we have this Oscar over here would be representing 1. Pointing directly east would be 2. Pointing down to the right like this Papa is represents 3, and so on and so forth. And that's the way that the 45-degree rotations work. So we have 3, 7, 3, 0, 4, 6, 5, and 2. Excuse me, 1. So let's get right into this and let's see exactly what we need to do. Now, one thing that's very important to keep in mind is that all of these, essentially all of these ciphers, what they're going to tell you is they're going to tell you the encryption process. So you need to essentially figure out how to reverse some of these things. And that's going to be very important. The one that is the most notorious for being tricky for this is the affine cipher, which I'm going to be able to explain in a thorough manner here. And let's get right into this. So first things first, we have to do Playfair. And Playfair is actually one that you want to set up immediately because of the fact that there's going to be, you have to use this essentially. And one important thing about Playfair is that they have to show up in pairs because of the fact that you have to use the Playfair cipher in order to sort of match the characters that you need. For those who are familiar with how Playfair cipher works, I will explain this in this tutorial. And also I will leave a link to all of the individual ciphers in here as well, because of the fact that it's kind of important to have this background knowledge, so that I'm able to explain this in a much quicker fashion. So let's get right into this. So Playfair cipher actually works a little bit different compared to the actual normal Playfair cycle in Jumble cycle here. So let's get into this and let's see what we need to do. Now, normally, if we take a look at what Playfair cycle wants us to do, over here, normally what would happen with this is actually this would be in 72-degree rotations, and it would actually be in base 5. However, in this case, it's going to be in 45-degree rotations, and it's actually going to be in 2 octal numbers, or in this case, base 8. That's going to be the way that this works. So that's really the key difference with this module. Otherwise, that's really all you're looking at. And the way the Playfair cycle works is the number of 45-degree rotations across all tiles, starting from north, of each pair of adjacent tiles are interpreted as 2-digit octal numbers. And the way that this works is if we take a look at this message here, what we need to note down is we need to note down every single possible pair that appears here. And the way that this is actually going to work is going to be 37, 73, 30, 04, 46, 65, and 51. That's going to be what we're going to get here. We're always going to get exactly 7 possible pairs present in here. So it's going to be the 37 that we have here, then the 73, then the 30, then the 04, and so on and so forth. And now what we're going to do is we're going to interpret this as base 8 digits. And the way that this works is it's essentially going to be multiplying each of these respective numbers. It's going to be essentially multiplying 3 by 8, which is 8 to the power of 1, and then adding on whatever is in the second digit, or in this case, it's represented by 8 to the power of 0, which is represented by 1. It's essentially multiplying these two numbers, 3 and 7, which in this case is going to represent 8 to the power of 1 is 8, and 8 to the power of 0 is going to result in 1. And essentially what's going to happen here is essentially it's like you're multiplying these two numbers together, and you're essentially adding them together. Essentially, that's the way that this works. So 8 times 3 is going to be 24, and then 7 times 1, which in this case is simply going to be 7, is going to result in 31. Now, if we happen to go over the 26 area, we're going to modulo this by 26. So, modulo this by 26, and this is going to give us the result of 5. Now, one thing that's very important to note down immediately is that we're going to be starting from A equals 0, so it's A0Z25. Very important to note down. So in this case, this is not Echo, this is Foxtrot. So this is going to be our first letter for the Playfair cipher grid here. So let's do the exact same thing with all of these guys here. So it's going to be 7 times 8. 7 times 8 is going to be 56, plus the 3 is going to be 59. Modulating this by 26 is going to be a 7. Not golf, but hotel. And now what we're going to do is we're going to do 3 times 8. Which is going to represent 24. This is going to be a Yankee. We're not adding anything else afterwards. It's going to be 8 times 0 here. Adding on 4, which is going to then be a Echo. Then we're going to do 4 times 8 here. Plus the 6 is going to be 38. Modulating this by 26 is going to be 12, which is a Mike. Then we're going to do 6 times 8 is going to be 48. Plus the 5 is going to be 53. Modulating this by 26 is going to be a 1, which is a Bravo, not Alpha. Then we're going to finally do 5 times 8 plus 1, modulating this by 26, is going to be 15, representing Papa. Okay, and now we've determined our starting characters in this original cipher here. And now what we need to do is we need to fill in the remaining 18 letters, because they're going to fill in the rest of the key square in alphabetical order, excluding X. Now, normally with Playfair cycle, you will actually exclude X instead of Juliet. And in this case, that stays the exact same, which is never used. So what we're essentially going to do is we're going to make it a 5 by 5 grid, and we're going to go alphabetical order, skipping over any letters that we haven't had already. And if we happen to have a pair that is the exact same, I actually don't think it actually happens to have. I don't think it actually is possible to have the exact same amount of characters twice, just based off of the way that it generates. But anyways, what we're essentially going to do now is we're going to skip over any duplicates from beforehand. These are always going to be in this exact position, and we're going to fill in the rest of the 18 letters in this key square in alphabetical order. So we don't have Alpha, we do have Bravo, we don't have Charlie, we don't have Delta, we have Echo, we have Foxtrot, we do not have Golf, we have Hotel, we do not have India, we do not have Juliet, we do not have Kilo or Lima, we do have Mike, we do not have November, we do not have Oscar, we do have Papa, no Quebec, no Romeo, and I believe the last character that we need to worry about is just the Yankee, so Romeo, Sierra, Tango, Uniform, Victor, whiskey, skipping over the X-ray, skipping over the Yankee, and lastly Zulu. Okay, and just like that, we have gotten our Playfair cipher. So now all we simply need to do is we need to put this aside. But first things first, we actually need to get our pair here. And the way that Playfair cipher works in this instance is we're going to take both of these letters that we have right here, in this case Papa and Tango, and we're going to find both of these positions on the grid here, which in this case is represented by Papa and Tango right here. Now, what this is going to do is each pair of the letters is altered in this fashion. If both letters belong to the same row of the key square, we're going to shift both letters one space to the right. Now, one important thing to keep in mind, remember, as I mentioned beforehand, this represents the encryption process. We're currently in the decrypting process because we need to remember that we're trying to figure out a word that has been encrypted in this gibberish mess that we have right now. So, make sure that you pay attention to which current process you are in, whether that be decrypting to find a word or encrypting a word into a message, because this is going to be very important to pay attention to the directions. So if both letters happen to be in the exact same row, what you would essentially do is instead of shifting right in the decrypting process, you would shift to the left, performing the opposite. That's going to be what you're going to do here. Same thing with the same column. It wants you to move down for the encryption process. You're going to move up for the decryption process. That's going to be very important. Otherwise, and this will always be the exact same, the letters lie on the diagonally opposite corners of a rectangle. The encrypted pair consists of the letters in the horizontally opposite corners from the original pair. So essentially what this means here is that we're going to find Papa and Tango. And what we're going to do is we're going to essentially build a rectangle out of this thing, and we're going to find the horizontally opposite position from Papa that would be forming the rectangle, which in this case represents Bravo. And then we're going to do the exact same thing for the Tango, which in this case is going to be represented by uniform. So it's going to be a Bravo and a uniform for these first two characters here. So that's what we're going to be doing with this module. We can get rid of these numbers, and already it's not forming gibberish. It has the possibility of being a word. We have, for example, bullhorn, bulwarks, that can appear. That's a good start for us so far. That means we're on the right track. Now, I'm going to do the rest of this module normally. But we need to remember, we need to keep this grid. We need to keep this grid for the respawns when we have to encrypt a word again. So let's keep that in mind. So now we're going to get into the infamous affine cipher, which in this case is marked by yellow. So affine cipher is a little bit tricky, and it's kind of been the bane of my existence personally, but it's not too bad once you understand how it works. So the number n for each dial is the number of 45-degree clockwise rotations from north to the direction the dial is pointing to. This number is between 0 and 7. And the reason why it specifically is referring to n here is because it's going to be used in this formula. Now, one important thing that we have to do here is we have to, and remember this is the encryption process, is starting from a equals 1, the alphabetical position of each letter is multiplied by 2n plus 1. 26 is subtracted from the product until it falls into the range, within the range of 1 to 26, or in this case, simply a modulo 26. It's modulo 26 until it is 26 or lower, because it has the possibility of it being actually Zulu here. So, and this is the alphabetical position of the encrypted letter. Now, what we essentially want to do is we want to do the exact opposite. And how exactly is the exact opposite performed? Well, first things first, we need to figure out what we're going to be actually looking at within this formula. So 2n plus 1 is going to be essentially, we're going to be applying the 3 here with this foxtrot, and it's going to be 2 times 3, which is going to be equal to 6, plus 1 is going to result in a 7. And essentially what we need to do now is we need to look at this alphabetical position of foxtrot, which is a 6. Keep in mind that the only time that we're ever going to have the a equals 0 is going to be in the Playfair cipher. Otherwise, the rest of the stuff is going to be treated as normal, in this case, A1Z26. So, let's take a look. So now, what we're going to do is we're going to apply 6 here. And now, instead of multiplying by the 7, which we received, which would be the normally the encrypting process, what we're going to do is we're now going to add 26 until we get a multiple of 7 from each of these numbers here. And we're going to have to kind of do this a little bit of guessing checking. So divide by 7 here. So 32 divided by 7 does not work. So we're going to now add 26 again. 58, is that possible? No. Another 26 needs to be added here. 84, is that possible? And I'm going to say that is a yes. So now, what we're going to do here is we're going to take this result, in this case 12, and this is going to be our letter. That's the way how we have to do this. And just like that, we get a Lima. Note that if we take a look at the two possible words that we could have been looking at here, Lima is the third letter. We did this correctly. So now, what we're going to do now is we're going to take a look at the Pigpen cipher. So now, Pigpen is a little bit of an interesting one, and it's one that I actually might have a little bit of a trouble explaining here. Each letter is translated using the Pigpen cipher below, and this is going to be the way that it looks. So, starting from north, the Pigpen characters are rotated to face the direction the dial is pointing. And the way that it actually is, the way that they are rotated is they're going to start off rotating clockwise in the encryption letter. The rotated Pigpen characters are then translated back as though they are still facing north to produce the encrypted letter. So, one important thing to note down here is the way that this works is it's going to be trying to we're trying to get it in the correct position that matches the, we're trying to rotate it a series of times that it matches the amount of times that the rotations are currently present in the module. In this case, Lima happens to be 0, so actually in this case it's going to be the exact same. But with Bravo, for example, Bravo is 4 times. Now, one important thing to note down is if you look at these positions, what's going to happen here is that it's going to kind of go back and forth. So we have Bravo here. Then if we rotate one clockwise, we're not going to go to Charlie, but we're going to go actually down to Kilo. And we're going to kind of go back in a back and forth fashion between these two grids. And that's kind of going to be the way that this works. It's a bit of a weird example. But essentially what you can actually do here is, if you think about it, if the number is even, it's going to stay. If the number is even, it's going to stay in the exact same grid that it's going to. However, if it's odd, essentially what you need to do is you need to transform it into the other grid here. I think that personally, the tutorial for Pigpen Cycle does a lot better job of explaining how this works. If you want to follow along with that, be my guest. But essentially what we're going to do now is we're not going to rotate clockwise because that's how we get the encrypted letter. We need to rotate counterclockwise. So we're going to rotate counterclockwise 4 from Bravo here. 1, 2, 3, 4. And we're not going to switch to the opposite grid, and instead we're going to note down Hotel. Next up, we have the white here. And hopefully I will be able to explain Pigpen in a little bit of a better way in another example. Next up, we have the uniform. Now for Caesar cipher, this one actually is the simplest one of them all. This one is probably a fan favorite. The letter has been shifted forward through the alphabet by the number of 45 degrees clockwise rotations from north to the direction the dial is pointing. So all we simply need to do is we need to not go forward, but we need to go backward for the decrypting process. So in this case, we're simply going to take the alphabetical position of 21, which in this case is uniform. We're going to subtract 6 from this, and we're going to get 15, which in this case is going to represent an Oscar. And we might as well do the same thing for this last one over here. I'm going to mark that with a question mark. Oscar, back 1, we're going to subtract 1 from this, is going to be a 14, which is a November. And if you can already see what the word is looking like, that's good for you. I'm going to finish this example by showing you how the last affine cipher works. So we're going to take the formula again. We're going to focus on the n part of this. So n is going to be represented by 5. So we're going to do 2 times 5, which is going to be a 10, plus 1 is going to be an 11. Okay, and now what we need to do is we need to start from 16. We need to keep adding 26 until we get a multiple, and until we get the first multiple of 11. Plus 26, plus 26, plus 26, plus 26, plus 26. 172 maybe? I think we're getting close. Nope, we're definitely getting close. Plus 26. 198 maybe? Yes, here we go. And now, we're going to take this value, in this case, this is represented by a Romeo, and that is going to be our letter for this position, Romeo. And now we have found our word for the bullhorn. Scroll down here. Bullhorn was our word that we found, and now what we're going to do is we're going to take the word below it, in this case, weapon, and now what we're going to do is we are now going to essentially encrypt this into a response. That's going to be the way that this works. So, let's get right into this. So, since now we actually have to use all of the ciphers, we actually cannot sort of shortcut this module. We have to use everything that we know. This is probably going to be a bit of an easier part for you guys. It's actually fairly simple. And now everything that you read in this manual is exactly what it wants you to do. So, let's get right into this. So we have Whiskey Echo here, and in this case, Whiskey Echo actually happens to share the exact same column in the Playfair ciphers, because these two are focusing on the cyan letters. So, we have Whiskey and Echo here, and they happen to be in the same column. So what exactly do you do in this case, in this situation? If both letters belong to the same column of the key square, shift both letters one space down the column. So let's do that. So we're going to shift Whiskey down 1, wrapping around, which in this case is going to result in Echo. And Echo shifting 1 down is going to result in a Charlie. That is going to be how we're going to get our answer for that. Now, we're done with the play first cipher. We do not have to use this anymore, so I'm going to simply get rid of this. Okay, because if you happen to strike, it actually will reset the entire module, and you will be given a new sequence of characters and in a whole new puzzle essentially to deal with. So next up, we have Affine here, and remember we had to find the multiplication of the 7 here, but now we're looking at this from the affine cipher perspective of the encrypting process. So now starting from A equals 1, the alphabetical position of each letter is multiplied by 2n plus 1. 26 is subtracted from the product until it falls within the range of 1 through 26. So now what we need to do here is we need to do 2n plus 1, which in this case, for this position, it was 3. So 2 times 3, which we agreed was plus 1, was 7. So now what we need to do is we need to multiply this position, in this case, alpha, multiply you by 7, which in this case is going to result in a 7. This answer is going to be golf for us. And in the meantime, we might as well take care of the other affine since we're right here. And remember, this one we agreed this was an 11. So now what we need to do is we need to multiply this echo by 11. So we need to multiply 5 times 11, which in this case is going to be 55. I'm going to get rid of these letters because these are going to be distracting for you. So this is going to be 55 because we are multiplying the echo that we have here. And we're multiplying it by the 2n plus 1 equation here. So now what we're going to do is we're going to modulo this by 26, and we're going to get a result of Charlie from this, in this case 3. Okay. And now let's take care of the Caesar ciphers here. I'd like to take care of the easiest ones first. This is going to be the letter has been shifted forward through the alphabet by the number of 45-degree clockwise rotations from north to the direction the direction the dial is pointing. So now we're going to shift forward by the rotation count. So in this case, November is going to be shifted forward 6 times, which is going to be a tango, because 14 plus 6 is going to be 20, that's tango. And delta is going to be shifted forward by 1, which in this case is going to be an echo. So, and then finally what we need to do is we need to do the playfairs. The playfairs are really simple, I mean not the playfairs, the Pigpen ciphers. So now, anything that is a 0 is going to be the exact same character in Pigpen. That's just the way that this works, because we're not rotating it by anything. So we have already the pop-up figured out. But now what we need to do is we need to rotate this Oscar 4 times. And we need to rotate this 4 times clockwise now, which happens to be the exact same thing if you happen to rotate clockwise or counterclockwise. It doesn't prove my point. But in this case, you want to rotate clockwise. And we're going to do this Oscar right down here. So, and one other thing to note down, each Oscar will result in the exact same thing if you happen to rotate it, I believe. In most cases, yes. As far as I'm aware. So we're going to go down to this Oscar. We're going to go 1, 2, 3, 4 over here. So now what we're going to do is we're going to hit Mike. And Mike is going to be our answer for this one. And just like that is a solved module. And now let's input this into the. It's not solved yet, but let's input this into the module here. We have our encrypted response that we're gonna input into the module. So we've got Echo Charlie Golf, Papa Mike Tango, and Charlie Echo, and just like that is a solved module. Now, I'm sorry for taking so long for explaining this. I wanted to make sure that I got all the ciphers explained well enough. And I'm going to do this next example a little bit faster, just because this module itself is not that hard to do. However, I would advise not rushing it. And I'm actually going to make my life a little bit easier by actually just getting only the first couple letters. I obviously was able to figure out that bullhorn was exactly the word that I needed here a long time ago, but I just wanted to be able to show you how each of the ciphers work and how it essentially gave me the answer that I needed to give. So I'm going to go through this and I'm going to show you how to do it a little bit faster. Though keep in mind that you will have to do Playfair cipher. It's just a guarantee. You have to do it at some point. So let's get right into this thing. Okay, let's see if we can get some more interesting examples, especially for Pigpen, because I want to be able to show this off. And we do actually get some more interesting examples. So We have Victor, Echo, Sierra, Bravo, November, Papa, Charlie, Echo. Noting down the rotations, we have 0, 2, 5, 5, then we have 2, and then 6, and then 7, and then 1. Okay, let's see what we can do with this. Now, one of the things that we can actually immediately realize is that what we need to do with zeros in the affine cipher would be 2n plus 1 equals 1, because if we have a 0 here, it's simply 2 times 0, which is 0 plus 1, and we're going to end up actually finding a multiple of 1, which in this case, everything is a multiple of 1 and itself. So everything is divisible by 1, except, well, yeah. But in this case, what I mean by this is that if we have a negative 0 on affine, it's going to be the exact same character. We don't have to change that at all. And we make our lives a lot easier by doing this. Now, let's take a look at this Pigpen. So now Pigpen is currently 2. We're going to rotate Echo 2 counterclockwise, since this is the decryption process. And one thing that you can immediately realize is that this is actually in the center here. So all we simply need to do is we simply need to keep it in the center, but we also need to make sure that we check the parity. It's even, so it's going to stay on the exact same board. So we're going to mark this with an Echo. Next up, Sierra. Sierra is the white label. It is a Caesar cipher. So we're going to be shifting backwards by 5 in this case. We're going to be shifting backwards, so that's going to be a 19 minus 5 is going to be a 14, which is going to be November. And already this is sort of forming out to be a suitable word. Let's see if we have any possibilities here. We have venomous and vendetta, and we will be able to determine which word we're looking at by based off of the next letter here. So let's figure this out. So we have the Pigpen cipher for the next one, and this is actually where I'm able to explain how this works. So the way that this works is we're essentially going to be going back and forth between grids, or you can simply say, hey, let's rotate by 5. If it's an odd digit, you're going to go to the opposite side in the exact same position. So let's take a look. So Bravo, we're going to go counterclockwise by 5, because that's the number that we're going to get. We're going to go 1, 2, 3, 4, 5, down to India, but India is not our word. And what we're going to want to do is we're going to go to the bottom right from the center. We want to go to the bottom right position, which in this case is Oscar, not uniform, Oscar. It's very important that you keep this in mind. And say, for example, if we wanted to go to the other grid, we want to do 1, 2, 3, 4, 5. We go to the other grid, it does indeed result in an Oscar. So whatever way you want to do this, it's going to be resulting in the exact same thing. So Oscar is our answer. And now we know from this that venomous is our word, and our response is going to be linger. Let's put this in here. We have our word here. Let's get rid of the encryption process. We don't need to worry about this. We only need to worry about the rotations now. And obviously we need to pay attention to the colors. And now we're going to get this thing going. So the same thing applies to affine in the encryption process and the decryption process. If it happens to be 0, it's going to be the exact same character, because what's going to happen here is you're going to be multiplying lima by 2n plus 1, which is simply going to be 0 plus 1, and you're going to be multiplying it by 1. It's going to be lima. So we know lima is our first character here. Now, from the Echo in the Pigpen cipher, what we're going to do is we're going to rotate 2 times clockwise. Echo is still in the middle. It's not going to change. Or excuse me, India, rather. We're going to rotate India 2 times clockwise. 1, 2, over to Gulf, and Gulf is going to be our letter here. Next up, we have November in Caesar here. Caesar is going to be shifting forward by the alphabet. So we're going to shift forward 5 times, which is going to be 8. You guessed it, Sierra. Next up, we have Gulf. Gulf is going to be rotating clockwise 5 times because it's Pigpen. So we're going to do 1, 2, 3, 4, 5. That's going to result in a uniform, because we're going to be, it's an odd number. We're going to switch over to the other grid here. And in this case, it's going to give us a uniform. Next up, we have the Playfair. So we did not create the Playfair beforehand, and now we need to actually create the Playfair. I'm actually going to leave these 2 with question marks right now, and I'm simply going to just take care of the rest of the stuff while we're at it. So we have an Echo in Pigpen, and this is going to be a number 7. This is going to be, we're going to rotate 7 times clockwise, which in this case, it's odd, so we're going to switch over to the other grid when we're done. So, Echo happens to actually be in the center. So all we simply need to do is we simply need to note down that, hey, we're going to be swapping over to the other grid, which in this case is going to give us a November. Delta is going to be a affine cipher of 1. So we're going to do 2n plus 1, which is going to be 2 times 1, which is equal to 2, plus 1 is equal to 3. And now what we're going to do is we're going to multiply this delta by 3. So 4 times 3 is going to be a lima. It's in the range of 1 through 26. And now what we're going to do is we're going to say that this is a Lima. Okay. Now for the fun part, we need to create our playfair group. So let's do this like such. So we have 0, 2, we have 2, 5, we have 5, 5, we've got 5, 2, we have a 2, 6, a 7, 1, and that's going to be, excuse me, a 6, 7 rather, 6, 7, and a 7, 1. Now remember, this is going to be in base 8, so let's take a look and let's see exactly what we need to do here. And let's get this thing going. So base 8, this is actually a fairly simple one. And remember, this is an A equals 0, Zulu equals 25. That's going to be the way this works. So, we have 0, which is going to be nothing, plus 2 is going to be resulting in Charlie. We have 2 times 8, plus the 5 is going to be a 21, which is going to be Victor instead of uniform. Then we have a 5 times 8, plus 5, modulating this by 26 is going to be 19. That's going to be a Tango. 5 times 8, plus 2, modulating this by 26 is going to be 16. That's going to be a Quebec. 2 times 8, plus 6 is going to be a 22, which is going to then be a Whiskey, right? Yes, Whiskey. Next up, we have 6 times 8, plus 7, modulating this by 26 is going to be a 3. This is going to be a Delta. And finally, for the last one, 7 times 8, plus 1, modulo this by 26 is going to be an Echo. Or excuse me, not an Echo, it's going to be a Foxtrot for that. So, now what we're going to do is we're going to fill in all the remaining characters that are not present in alphabetical order, and we're going to get this thing going. And of course, skipping over X, right? So we've got A, B, C, D, skipping C, D. We have E, we have an F present. G, H, I, J, K, L, M, N, O, P. Then we skip over Q, R, S, we skip over T, U, V, we skip over V rather, then we skip over W, and we do Y, Z. Okay, and now what we simply need to do is we simply need to look at E and R in this grid. E is right here, R is right over here. We form the rectangle, in this case it's going to form with the Delta and the Zulu. Echo is going to be encrypted to the Delta, and Romeo is going to be encrypted into the Zulu. And this is going to be our final response for this module. So we have Lima Golf, Sierra Uniform Delta, Zulu, November, and finally Lima. And just like that is a solved module. As always, thank you guys for watching. Remember to stay crazy, stay cool, and I will see you guys in the next one. Bye-bye.